Greeting everyone and welcome on this new lesson. Today we will learn how to control the step motor using the integrate as the sine function. So end of this course we will be able to plot this graph, this cosine function. So we will first define our parameter as this first one is the cosine function at 19 degree. First of all, we're using simulating base of the MATLAB software. The second type is to input our different parameter, plot to the interface, and the final use the command plot to that graph into the command interface. What does that mean? It's that we use the mathematics to solve and also to control the step of our motor. So let us quickly go through our software. First of all, we need to create the new project and then add those elements as the sine wave function, the sine wave, and then the integrate, and then I need to show in the graph. I need the graph to plot the evolution of our curve. So either using another graph, it should be better to use the XY graph. Why? Because in this case it requires the sine function and also the time. Well, in this situation, as you can see, we have two input. So here is our integrate, and then we want to plot in function of the time. So how to connect the time? To solve this, we need to add to take the time as the clock. So I will take the clock as my time, right? And then drag it into this input. Okay, then we assign our value. So we first define our initial integrator as -1, and those parameters we can keep it like this without changing. This is our amplitude and also frequency. Can be also changed as your need. And then we need to calibrate the time. Let's keep it at 10 seconds. And then where it becomes very interesting is in this phase. We define our x minimum value as 0 and the maximum as 10. And we can also define here the y-axis minimum as -2 and the maximum as 4. And then we assign it. Well, let us run and see. Okay, so here is our curve, our sine function, cosine function. On this lesson, I will not keep it like this because we want to achieve or we want to solve some we want to have more idea about this function, and also to have the numerical value. So to do that, we can also assign the scene output, so that we can make it very interesting, and also more useful. So we drag this scene output, and then I will simply copy and paste. That's where things now comes interesting. Okay, and then drag into the time. So we define it as input, and then do not forget to change this option, otherwise it won't be show you that graph. Put it as error, and then the same, do the same on this second, name it as output, and then change this option as error, and the same as here, we name it as the time, and we must change it as the error. Okay, so let us plot it and see. So that's the same curve that we got the last time. Well, move on of our command interface. So to be able to plot the curve that I've shown you previously, we need to add this command as plot. We can also from the workspace see those different values, so that we can be also able to write it as you can see. Well, so we can simply type the time input, comma time, comma output. What do that mean? Simply means the time which is noting that the x-axis, this is a y-axis, x-axis, y-axis, right? And then press enter. So this is our graph, the final graph that we got in this exercise. Okay, so let us make it very interesting by showing by put the gray on, so that we can see it very clear. Perfect. So the first one is the sine function at 90-degree phase, okay, from the integration of the cosine. Okay, and then that's showing the integration of the sine function, right? And this is the initial value was defined by our parameter input. Okay, so what we're doing here is that is doing the numerical using a little bit using a little step. So using the small step, you can control the small step using the numerical integration. Then you can specify the tolerance of where we are. So what do that mean is that we use the small step, okay, using the numerical integration. So you can also change the different value as your need, and then to specify the tolerance of the integration. So anyway, that is the numerical integration. So you can use it to control your motor, and also to have the curve as your need. Okay, so that is the basic idea, and also the basic information that we wanted to share with you today, you guys. So thank you to watching this video, and see you next time. And if you are new here, consider it and subscribe, so that you won't miss any other interesting video. That's how things supposed to be. Thank you.